Hello, everyone. Thanks for tuning in to today's fireside chat with Renault from Plaid. I'm Kevin. I'm the co-founder and CTO here at Tecton. But let's spend much more time talking about Renault, his background, and what he's been up to over at Plaid. Renault, do you want to just introduce yourself for a sec?
Yeah, my name's Renault. I work at Plaid, and we're a fintech company based in San Francisco. We have about 1,000 employees, and I think our value add is to allow people to connect their financial institutions to any fintech app or service quickly. Yeah, I started out as an ML infrastructure engineer in the company, and now I'm on the Signal team.
Excellent. Thanks for that. And maybe before we dive much deeper into Signal and what Plaid does generally, what did you do before Plaid?
Yeah, before Plaid, so I joined Plaid in April 2020. Before that, I was at Cruise on the site reliability engineering team. I was embedded with the data infrastructure team. So working on data ingestion when the self-driving cars come back to the garage, and spent another year and a half working or embedding with the ML platform team. Mostly focused on reliability efforts on experimentation. And then before that, I was in the East Coast in Connecticut, working mostly on platform as a service and a little bit on job orchestration.
Excellent. So lots of experience working on platform teams and lots of experience with putting real world ML applications into production. Very cool. And then maybe for Plaid really quick, like what's the best way for folks to think about Plaid and where may they have even interacted with Plaid without really realizing it?
Yeah, I think our classic example is Venmo. So if you sign up for a Venmo account right now, you might see a Plaid prompt that says, hey, do you want to log into your bank account and we can help transfer money into Venmo so you can pay someone else? Yeah, that's a simple example, just some sort of open financial API that we connect with FIs, financial institutions, and it would just help you set up your new fintech app easily.
Excellent. So Plaid is really an API on top of fintech institutions. So that makes it very easy for developers to integrate with different banks and whatnot. And it's just all going through one standardized API. Excellent. Cool. So when you joined Plaid, if I'm correctly informed, you initially joined their ML platform team, correct?
Yeah, so in 2020, we didn't really have an ML platform team. So my focus was around how we can set up the data foundations so that we can start working on ML platform. So yeah, ML platform really started around Q1 of 2021. In 2020, I feel like we needed to have a better data lakehouse setup. We needed to have better orchestration. So we productionized our Airflow on-premise setup. There were a few prerequisites that we needed to hit before you can have like a self-serve ML infrastructure team that focuses on just ML ops.
And how many use cases did you already have in production, like real ML use cases that weren't using the platform, but that were kind of just ad hoc productionized without a platform?
Less than 10. And it was a little scary back then because a lot of these ML models haven't been retrained in a while. And then I'm just like, oh, wow. What if we delete these model artifacts by accident and things like that? But those are heydays, and we're much better than that now.
Yeah, I can relate to that. Like before Tecton, I was at Uber, part of the folks who started the ML platform team over at Uber, and that was the exact same situation when we started Michelangelo, with a variety of different models already in production, but very little structure behind it. And cool, very good. Curious if you can shed a little bit more light about on the team and the structure of the ML platform team at Plaid that you helped build, and what types of use cases it ended up supporting.
Yeah, I think one of the coolest things about the team is the diversity of ML products there are at Plaid. So you can think of, bank transaction data. There's a large scale, and we have description fields in there. So there's a lot of room for natural language processing, and then maybe more LLM. That's a new hotness. which we can talk a little bit about. And there's also understanding, building lending, allowing lending fintech customers figure out what a person's cash flow is. So predicting recurring expense deposits. And of course, there's Signal, which is a team I'm on, and that predicts the likelihood of a ACH debit transaction return. And so it allows you to make funding decisions and other things that allows fintech companies to control the ACH hold time and that sort of thing. So yeah, I will say there's like a fair, and there are a few more internal ML applications that I'm not really allowed to talk about. I'll say the diversity of ML is what makes the ML platform team interesting, because you have the support of these high variety of use cases, ranging from tabular data ML to deep learning, LLM, that sort of thing.
Interesting. How big is the team? How many ML engineers and other roles are on that team?
We fluctuated. We started out with 3 people. I think at prime time it was like 7 or 8 of us. Now it's down to 4 people.
Got it. Very cool. And what is that may be interesting for the audience to hear, like what's generally the stack of that ML platform? What different
For orchestration, we rely heavily on Airflow. And training, we use SageMaker for the most part. For model registry, cataloging, MLflow, inference, mostly SageMaker endpoints. We only do real-time inference at the moment. And we make heavy use of S3 for and maybe in Hudi, open source project of Hudi, to manage our training data sets and upstream data.
Got it. And then for the feature platform, what do you use there?
I intentionally left that out, and it was yes, almost entirely on Tecton at this moment.
Excellent. Quick little plug. Cool. Is there anything that you can share about the future vision of the team and where the team's going?
Yeah. We would like to expand adoption of Tecton for sure. So we're in the middle of this fairly large migration. We'll talk more about this, but we built a homegrown feature store before, and we're migrating that workload to Tecton. That's more in the short term. Long term, there are more other data challenges we want to tackle in my mind. So I'm always thinking a lot about data. So data quality monitoring, and also making streaming ingestion, change data capture events more ingestible to the ML platform.
Excellent. Okay. And you already mentioned LLMs, and I'm sure a lot of folks in the audience are going to be curious to hear how the ML platform team at Plaid is thinking about using LLMs, or whether they're already using them, what use cases they're looking at using them for, etc. Anything that you're allowed to share here, I'd appreciate.
Yeah. So if you Google Plaid API docs, and when you go to the landing page at the top, there's a search bar. Click on it. There will be something called Ask Finn experimental. So Finn is our chatbot, and it's using I can't say too much about the implementation, but it's a large language model that basically gives you a better experience for querying our API docs and YouTube videos. It even helps seek to the correct time of a YouTube video to describe or try to answer any questions you have.
It can, that's interesting. So it can seek to a YouTube video that may answer the question that you just asked and like go to the right spot in there?
Yep. Yeah.
Oh, very interesting. I'll just ask you may tell me that you're not allowed to share any details, but is it like a internally trained model, or a fine-tuned one, or an off-the-shelf one that you combine with?
So the developer relations team will publish a blog post and talk about this publicly at a later time. So I won't steal their thunder at the moment.
Good. Okay. And then I'm also curious, like now that you have this ML platform over at Plaid, are there still use cases that are not running on the ML platform and that are kind of running in the shadow outside of the platform? or is basically everything running now on the platform?
That's a good point. I would say some of the legacy ML models are still running in the shadow. The plan is to build new models that kind of allow us to sunset all these older ML applications. We're almost there, just like a few stragglers left.
Got it. I hope that the stragglers at least get retrained every once in a while, in contrast to what you mentioned very early in the call.
Right.
Cool. What's the rough breakdown, by the way, between structured and unstructured ML problems that you're tackling with ML platform?
It's a pretty good 50-50 split at the moment.
Interesting. And batch versus real time?
Almost entirely real time.
Interesting. Really, almost entirely.
Yeah.
It's fascinating. Yeah, when we started Michelangelo at Uber back in the day, we initially thought that we'd have 80% batch use cases and 20% real-time use cases, and we actually found the exact inverse. So also way more real-time ML use cases than batch use cases. Seems like you may even have a higher ratio than 80 to 20.
I think part of the skew is also attributed by the fact that we started out real time and then we just improve our platform to make real time serving easier, and as such, everyone just kind of went that way. We don't, but that's not to say that we don't have features that are computed in batch.
Yeah, makes sense. So you have batch computed features, but they feed into real-time predictions.
Correct.
Makes sense. Okay, cool. Excellent. And then you were on the platform team for a while, and then you decided to switch over to the Signal product team over at Plaid, right? Can you maybe help the audience understand what is Signal all about, and how should they think about the relation between that and Plaid?
Yeah. So Signal predicts the risk of a ACH debit transaction. And let's take an example. Yeah. So Kevin, you're starting a brokerage firm, and people are complaining like, "Hey, I want to buy Bitcoin when I sign up, but it takes 3 to 5 days for my ACH transfer to fund my Kevin brokerage firm account." And people will you just lose conversion that way. And so to give you instant access to funds, potentially you can predict how likely is this ACH transfer gonna go through, right? If the likelihood is high, then you can pre-fund their account and let them buy their Bitcoin now, increase conversion. And the obvious question to ask is like, why not just check this person's financial institution's account balance? If I'm trying to transfer $100 in to buy Bitcoin, if there's $100, we're good, right? But in reality, it's not that simple, because what if there's like this person pays rent on the 5th day of the month, and then you're having like that person's also trying to transfer in on the 5th day of the month. So it's possible that ACH transfer will get denied, person gets overdraft fee, no one's happy. There's also the consumer identified fraud, which is what if this person's account has been taken over. So you also want to predict that, and you can't know based on just looking at someone's bank account balance.
Interesting. Okay, so you're basically you're looking both at, you're trying to identify whether there may be actually fraudulent behavior going on here, like a account takeover where a person is not even authorized really to initiate the transfer. Then secondary, even if you may be authorized to do the transfer, you want to predict whether the transfer is actually going to go through, because you've got this whole delay, and the ancient banking world is going to take 2 to 3 days to actually process, and you want to predict whether 2-3 days from now the money's actually going to make it onto the account. Is that
exactly
right? Interesting. Okay, cool. And so you use machine learning here. Have you always for the get-go been using ML there, or did this maybe start at some point using just hand implemented rules, or like anything that you can share there about the evolution to using machine learning will be interesting.
The Signal product was started development in late 2020, or sometime in 2020, and it was publicly launched in November last year. But so I can only speak from what I remember. I believe it was it started out with the XGBoost model, and that's still what we run today in production. And so the evolution has mostly been, fine tuning or handcrafting all these features from the beginning, and then now to having a more methodical method as to what features to feed into these XGBoost models. And then there's a more involvement to setting up this prediction pipeline. And previously, it was just like one ML model that spits out a score, but now we actually have an inference pipeline. So ML to begin with, actually.
Got it. Can you tell us, so you told us it's an XGBoost based model. Anything you're allowed to share about the types of features that you're actually using to feed that model? I'd love to hear.
Yeah, we have a few classes of features or types of features. Some of them are pretty basic. How long has this person been banking with this financial institution? The longer, probably the safer. For example, there's also a bank transaction feature, which is like the types that the kind that I think about the most because of the high skill. So you can look at a person's cash flow, and there are other types regarding to information changes about this financial institution, that sort of thing.
Got it. Okay. And then Mason is asking what features are used in the account takeover prediction. Are those similar features or anything you can share here?
I probably can't share the specific details, but you can think about the realms of if the person's identity has been taken over, right? And so there's actually a class of sensitive personal identifying information that derive features, and we treat them very securely, and we take a kind of different route because everything is like PI derived features. I'll say, yeah, that's kind of like the something special about the consumer identified fraud.
Yeah. And then Mason is also asking whether the models are for account takeover and the ACH returns, whether you're outputting a probability of the return happening or whether it's more than that.
Yeah, it's a probability, risk tier, and a bunch of key value attributes. So this is all in the Plaid Signal API docs. If you look at the doc, it's the /signal/evaluate API endpoint. And we try to give you a recommendation and it's ultimately up to you as a fintech developer what to do with the score. Like for 30, what's my ACH hold time? Risk score of 60, what is it? And 90 plus, you probably shouldn't initiate the ACH transfer. So you make the determination. You have to figure out your decision thresholds or cutoff. But we have other attributes to help you figure out what's the best number. And actually, this is a little bit of a back and forth as well, because it's helpful for you as a user of Signal to kind of collect data over time and figure out for your use case, what's the best way to improve conversion without having a lot of losses as well. So you might want to consider moving that threshold over time.
Yeah, makes sense. And then to the extent that you're allowed to share, I'm curious also, like, how do you actually collect the labels? Because like anytime that you actually reject a transaction or anything like that, that's an opportunity, or that's basically a missed opportunity for a label where later on you don't know whether this would have actually been fraudulent or not. Curious if you can share anything about the strategies you're employing there to collect good labels to actually train your models on.
Yeah, part of it is we rely on the clients. So you, Kevin, if you're the brokerage firm, you can report your decision. So whether you actually initiate the ACH transfer after you call this evaluate endpoint. And you can also tell us what happens to the ACH transfer, whether it goes through or not. And so we're partially relying on the network effect to help the model get better for every customer. That's one aspect. The other aspect is potentially making educated guesses as to whether these ACH transfers have gone through or not. And that's a lot trickier. We typically treat data that clients send us as much higher importance.
Makes sense. Okay, very cool. Now I've got another question in the chat here before we move over to my questions again. What tools do you use to help with feature engineering and feature selection?
Mostly homegrown, and so there's room for automation here, but there's SHAP value comparison, and just looking at the feature importance per feature. Then we have feature, this is being actively developed, which features are good, which features we shouldn't use, which we should deprecate. Because as you know, XGBoost model, once you train the model with this feature, it's kind of hard to deprecate that. But internally within our system, we want to say, for the next set of models that we're going to train, don't use these because we're trying to sunset them. And only until all clients are off of the older ML models, then we can slowly deprecate these older features. So easy to add new features, but much harder to get rid of them. So we've built more systems in place to facilitate that migration.
Got it. Okay. And Daniel has a question here of whether you're making your model results actually explainable, and if so, how you do that.
I would say the core attributes are helpful. Otherwise, we also launch a portal or a dashboard, and we call the signal dashboard that we launched a few months ago. Over there, you can probably see what you'll see new developments as to we're trying to improve that explainability aspect. But right now, you can see the correlation between what these attributes are versus what the scores are.
Excellent. And are you using the ML platform entirely for the signal use case?
Yes. I hesitated because we're migrating to Tecton. So I was going to say we're going to be fully on Tecton, but that's in the process.
Okay. And then given the migration and everything else, I'm curious if you can shed some light on some of the most interesting technical challenges you've experienced in developing the signal use case.
Yeah, for me, it's the mutability of our bank transaction data. So let me explain that a bit. So if you log into your bank account, you will see I have bought this cup of coffee, I paid my rent or whatever. And those bank transaction data actually need to be reconciled, matched, and updated. And sometimes the status can go from pending to posted, or you say this, you dispute a transaction and it gets deleted even sometimes. So this mutability of data basically makes for tricky late arriving data, consistency, data handling behavior. So what we were thinking was, okay, just assume all bank transaction data will only be mutated up to 7 or 14 days. And we'll take anything beyond 14 days, which is our watermark in our Spark structure streaming application. We'll just ignore and say, we'll take that as loss in terms of data accuracy. But it turns out that's a pretty big downgrade from what we've done with our homegrown feature store. So we decided to use Tecton's ingest API to solve this problem. So it kind of helps us not think about the memory footprint trade-off with data accuracy and just say, hey, if our microservices are going to have bank transaction data at this point in time, we can feed them in and get high data accuracy and just let Tecton handle the aggregation. So yeah, I would say just generally, our upstream data are developed in the first place to make products easier, but they aren't making immutable event or change data capture easy, because it's more of a, when you're an API first company, you don't think about like, I need to make sure all of our data systems are immutable and we have event timestamps for everything. So that's sort of a challenge we have to go through in order to get feature value reproducibility.
Interesting. Let me echo some parts of that back to make sure I fully got it. So you've got these mutable events because you have transactions whose state may change. Like for instance, I have a transaction that's currently pending, and then a couple days later it may actually go into rejected or completed or something like that. And given that, you need to be able to like if you have these transactions actually feed into an aggregation or something like that. Like for instance, if you say give me the count of pending transactions or something like that, you need to be able to actually take into account the updated state of that transaction. And I already say something interesting about using Spark structured streaming jobs to run aggregations like this, and the watermark threshold and the memory footprint there. And basically what I already say is that the longer the watermark threshold is, meaning the longer the time period is that the Spark streaming job keeps in memory, the longer the time period is, the higher the memory footprint is. And can you say a bit more about why that is a challenge and what problems you'd run into if that memory footprint just grows?
Yeah. So I think maybe some sense of scale, we have about billions of bank transactions over the span of a year throughout our system globally. So if we want to pre-compute features for the universe of signal possible users, we're looking at close to like billions of bank transactions that we want to maintain in memory if we want to get 100% data accuracy. So loading them up, not to mention a lot of the fields are text, like think about the description. That's pretty large payload size. And when your Spark structure streaming application restarts, you have to load everything up again. And it just makes it pretty intractable to maintain the system operationally.
Yeah, that's something I've seen quite a bit in the wild too. Okay, excellent. So that allows you to reduce the memory footprint and just not have to deal with it. Cool, very good. So now that you've got now that you use the Stream Adjust API to support these streaming features, I'm curious, are you generally able to, when you generate the training data, are you backfilling your features, or do you use feature logging in order to generate the training data?
A combination of both. So feature logging allows us to know the feature value during inference time. If you use ingest API, you could also get what you call get historical features, right? If you want point in time exact correctness features for training purposes, you can also have a batch data set that's basically a immutable event data set. But because we don't really have the latter, we basically snapshot the state of the world at the time of a request. So basically, because the data are changing so fast, and we don't have immutable event records saying this field has changed from this value to that value every time a piece of data changes, we say, hey, when you make this ACH transfer and you ask us to score the riskiness, this is what the state of the world, this is what the set of bank transactions at that time. And we store that in protobuf format actually, and we have to denormalize that into Hootie tables that are much easier to query using Spark. Once we have that, you can say, okay, I want to create this feature. And you can say a year ago, this ACH transfer, we messed up. We scored it very low risk, but somehow it got returned or whatever. You can say, oh, my new feature improves that example. And you can say, or have the upstream data source exactly at that point in time. So you basically have highly accurate, reproducible feature value if you snapshot all your upstream data sources.
Interesting. Okay, let me echo that one back to you too. So basically your operational data itself in your database is basically is fully mutable. So you always just see what does the state of the world for transactions and whatnot look like right now. But as you generate the training data later on, and experiment with new features, you want to know what did this operational data look like at a given point of time in the past. And so what you're doing is that you're actually, whenever you're making a prediction for a given user, you actually snapshot the data, the transactional data that you have in your operational database, and then you put it on S3 stored using the hoodie format, so that later on, as you experiment with new features and whatnot, you can always go back and basically execute time travel in order to generate training data that tells you exactly what this data looked like in the past. Is that correct?
Correct. And mechanically, what this looks like for Tecton is we'll have a separate feature view that uses these custom time snapshotted data sets to generate new experimental features.
Got it. Interesting. Okay, very cool. And then Gustavo is asking, in fraud platforms, velocity features are critical. How do you deal with this kind of feature? Are these features used in rules, or are they used to score a model? Anything you've got to say about velocity features?
Yeah, so we have new features in place to capture more of this velocity, so to speak. But we have work on our side to better figure out what the look back window is. So should it be like minutes? Should it be hours? And obviously we don't want to just like have a bajillion look back windows, because that's also pretty expensive to aggregate just over multiple look back windows. That's the first thing I'll say. The other thing is that we take advantage of on-demand feature view or ingest API to get very low latency accurate features. So for example, if a fraudster has been making a lot of ACH transfer on behalf of someone else during account takeover, they might do it within the span of minutes. And we, in the on-demand feature view, we can also get all the previous ACH transactions that were initiated and then look for patterns. And on-demand feature views are basically instantaneous, almost. You just, in the online world, as long as you store what the previous transactions are, you can feed them in to your system. So basically, there are two classes of transaction features. One is something that we can store in our database and feed them in directly on the fly, the more traditional feature computation on the fly kind of framework. Then there's one other set that takes in much larger transaction history, and we have to pre-compute them because they just take a long time. And we do have a API SLA latency around, within seconds, basically. And we can just have all that pre-computation work in the online path. That would just slow down the API endpoint.
What does your breakdown roughly look like of these batch computed features versus stream computed features versus full-on on-demand computed features?
More, I would say, in terms of just feature count, most of them are pre-computed. But the on-demand features, the ones that are computed on the fly, the data sources are fairly diverse.
Okay, cool. And then I have an anonymous attendee asking, do you feed large number of features at once and iteratively omit uninformative or subsumed ones, or did you grow feature set organically?
The latter. Yeah, the number of features have definitely increased over time. Pretty classic feature is easy to add and hard to remove. Tech debt. And yeah, we're definitely trying to address that with a system to figure out which feature you're adding is redundant and consolidate our feature. So that's very much in the works.
Yeah, that leads me to another question of feature experimentation. Like, how much iteration do you actually are doing constantly on this use case? Like, do you try out new features every single day, or is it mostly a static feature set and you may update it every couple months?
More the latter at the moment. And partially, we want to make feature experimentation easier once we're fully adopted onto Tecton. So part of it is a friction It takes such a long time to craft a training data set, do your feature joining against like 3 years worth of data, and then evaluate the results. And so, yeah, there are other higher ROI activities at the moment, unless we can squeeze this feedback cycle down.
Got it, yeah. And Tecton hopefully should help you doing that. Excellent. And then Adwait, hope I pronounced it correctly, is asking, do LLMs also evaluate risk levels associated with customers or loans or investments, or is it basically completely unrelated from LLMs and it's a fully supervised prediction problem?
I'm assuming this question is targeted to our signal directly.
Let's assume so.
Okay. So Signal doesn't use LLM today. And the use cases vary, but the main thing is account funding and payments and money movements, that sort of thing. Lending use case, there is a kind of separate product on that.
And then Christopher is asking, when someone identifies a new feature that can be useful to models, how long does it take for the feature to be evaluated across all the models?
Yeah, that's a good question. I'm gonna go with a small number of weeks at the moment. Yeah, so we'd like to get that done within a week.
Still not bad if it's just a small number of weeks. Very good. And then Tony's asking about false positives, whether false positives are reported back so that you can later on use those false positives for retraining.
Yeah, for sure. We hear both sides of the spectrum. High risk transaction goes through and clients are not happy, or the opposite, right? So both of them are highly important examples for us to incorporate into our training data set.
Got it. So basically, and I guess especially with the ACH returns, you're in a good position here because you would say, hey, this probably will not go through. But at the end of the day, your customer they're just going to say, okay, I guess in that case, I'm just going to wait 2 to 3 days to see whether the money comes through, whether I actually add this money to the balance and allow them to buy stocks or Bitcoins. And so you will definitely down the road see whether there was actually a problem here or not, versus say if it was credit card transaction fraud or something like that, and you'd say, okay, this is fraudulent, and then the transaction is immediately getting rejected, you would never down the road be able to understand and see whether this was actually a false positive. Is that right?
Correct. The ACH hold time plays a fairly large factor. And another thing is like, what if you have some ACH that your direct deposits coming down, your account balance doesn't take into account, and we think, oh, you're actually pretty low in balance, pretty risky, and then you got a large sum of money the next day. So many factors come into play due to the settlement periods, the variability of it.
Mm-hmm. Yeah. And then Bobby is asking, how do you evaluate model performance? Do you have hand labeled data, or do you basically just use the actual data that you're collecting from the clients? It's basically what you said earlier, right? Like you're using all the good data from the customers. Is that basically the full labeled data? Okay.
Correct.
Here's an interesting one. Cold start problem. How did you generate your initial training data before you ever launched Signal? Or did you just use heuristics back in the day?
Wow, this is before my time. I can't tell you. Sorry. But I have some guesses, which I shouldn't theorize at this point.
Cool. Are there any best practices or words of wisdom that you want to share that you haven't shared already that you'd like to share with the audience?
I would say the first one is naming is important. So as part of this migration to Tecton, we noted some of the features are named inconsistently. So consistent naming as to where do you put the entity, where do you put the description, what is this feature about, what the look back window is, start and end. Just having very strong consistency there will just help your feature definition look a lot cleaner. You can like do more programmatic for loops, for example, and stuff like that. and just for easy for allows people to understand your features more easily. Hopefully the name can mean a lot. Basically, that's what I'm saying. So more self-documenting feature name. Another one is settle on a good or agreed upon continuous integration delivery practice for feature development and shipping the features. So figure out what your unit test should be testing and what your integration tests in this feature creation should be testing. And maybe third one is like have a good handle on what sort of data you'll be using to create features. So if you have sensitive PI, you got to treat them very carefully. And we are very careful with like encryption, decryption of sensitive data. And especially we're financial, like we have people's financial data, and that's very important. So figure that out. I feel like everyone's infrastructure is fairly different. So for us, it's pretty important for us to just consolidate all of our infrastructure in one place so we can inject the same kind of auditing observability tools in one place instead of like in multiple database accounts, multiple data planes.
And that's one of the key benefits of having a centralized platform, right? That you just have to do all the data governance work just once, and all the standardization that comes with it. And the question is just how do you get people to actually use this platform? Because you can't quite force it typically. Yeah, that all reminds me back of my time over at Uber. Cool. Then Brian is asking, are you making any calls to vendors via external APIs in your online prediction flows?
That part, not at the moment. So yeah.
Got it. And then there is a question here on whether Tecton accommodates those outbound calls. I'll just take this technically an on-demand feature view, which are these real-time executed features in Tecton. You can execute in there whatever you want, and you can call out to an external API too. And actually, Q4 we're working on something to make that user experience even better, because those types of features do come up pretty often for these types of use cases. Cool. Mijo is asking, which score metrics do you use, and have you used k-fold cross-validation?
Oh, I think that was mentioned before. Actually, I can't tell you right now what the status of the k-fold validation is in our setup. Sorry, I have to check offline with the core modeling team.
And then, so you mentioned a few times that you are using Tecton, you're migrating over to Tecton as the feature platform. Curious if you can just share with the audience, hey, when do you think it's a good idea to use a feature platform like Tecton, and when would it actually be overkill?
Yeah, I'll say if you have a small ML infrastructure team, you should really consider Tecton if you have structured data that are base ML models. You also want to make sure you do have an ML infrastructure team, because I would say you need 1 or 2 people to maintain that, keep that Tecton infrastructure up, especially if you want to have an on-premise hosting. So those are some caveats. Super important if you want highly reproducible feature values. That's one of the biggest value prop for Tecton. And a nice UI and declarative configuration such that you can build your own continuous integration delivery platform. If you have your own opinions about that, the declarative syntax really is awesome. And obviously, I'm biased because I was an SRE, and I spent a lot of time in Terraform, and the just resonates with me, the declarative aspect. As to when it could be overkill, if you have a lot of feature transformations that are non-standard, aggregations that are just pretty odd, or if you have a lot of custom libraries that you've developed or off the shelf that you're using that are pretty non-standard, then Tecton might be hard to retrofit, so to speak. I believe on-demand feature views and some other feature views will have more like custom like dependencies that you can inject into the runtime environment. So that would be helping. But for us, we have a lot of new use cases that we could onboard onto Tecton directly. So that was awesome. And most of the aggregation methods are fairly straightforward. So that's just very helpful to get the ground up running and get impact by using Tecton.
And then Arwind is asking, do you spend a lot of time pre-processing the data that your clients send to you in different formats? Or is it basically just one standardized format that you force them to send it to you and you can just take it in?
Yeah, we have a API request that expects a certain schema. So it's fairly easy.
Cool.
Yeah, it's yeah.
Then Dwight is asking, assuming that financial data sets are huge, do you use feature selection to identify the useful features from the data sets?
Yeah, that's been experimented or prototyped a few times in the past, but not productionized. So at the moment, all of these features are manually reviewed.
Got it. And then you also mentioned earlier that you're using Chablais values to basically see what's actually the usefulness of the features, right? And then I guess you can throw out the ones that are not super important, so you're not spending money on them.
Exactly. And then we want to get better at also just having statistical methods on each feature value, what the range is, null percentage, that sort of thing. So right now we have reports for that, but it still relies on a human to look at the reports and figure out, hey, this value upstream data source doesn't seem super reliable, questionable data quality, we shouldn't use or derive any features off of them. So at the moment right now, there's like a lot of dependencies as to what makes a feature good or not. And yeah, we would like to automate more bits of that.
Awesome. And then another anonymous attendee is asking, what are your learnings from handling imbalanced data sets? Did you experiment with both supervised and unsupervised methods? And if so, which one worked better?
I think part of a previous question around k-fold cross-validation could be helpful in this case. Again, I don't know what the status of that is as to how we're using it. Otherwise, I think we have fairly custom sampling strategies to figure out which sort of risky, non-risky examples we're using in our training data set. And also just having a better notion of what the test data set should be. So just coming up with a more clear-cut, well-defined hypothesis and testing methods is helpful here.
Excellent. And then last question that I've seen here, and by the way, if anybody else has any more questions, please throw them in the chat or much more in the Q&A section. I think we'll have another 5 minutes or so to go through them. How do you evaluate feature importance before spending time to basically productionize features? Do you just basically backtest them and you look at that and then you just fully trust it, or do you actually test features in production?
I would say a mixture. If the Shapley value is high and it's clear that it's not a redundant feature, let's ship to prod and see what happens. By shipping to prod, I mean you can always create a feature. We can start logging it. It doesn't have to feed into a production ML model. We can do offline model scoring against a bunch of challenger models and then evaluate the results afterwards. Alternatively, as you said, you can also backtest against historical data and then model score those. So a variety of methods. I think one key variable here is how easy it is to backtest. Some data might not exist until it starts getting logged in a forward-failing fashion. So if that is a constraint, then potentially you need to adopt a different approach.
Another interesting question, are you pre-computing for all potential Signal users or just people who have previously actually used Signal?
Yeah, this is a cold start problem in terms of feature pre-computation. We do not pre-compute features for the entire Plaid user universe because that's a little too much data to pre-compute. So what we do is if we see that this user is linking their financial institution account with Plaid and might use Signal, we pre-compute. So we have some custom logic in there to pre-compute as quickly as possible. But then we also have one last last ditch effort, so to speak, just right before you're about to use signal, and we know for certain you are, then we'll grab as much data and pre-compute them as quickly as possible. Otherwise, we fall back to feature computation on the fly and potentially suffer some latency issues.
What's the budget that you have, by the way, for latency?
It's somewhat variable because the fintech use cases can be different. If you're trying to do ACH transfer to do like a real-time checkout experience, so the latency needs to be within seconds. And some clients have a higher tolerance if it's like, hey, I just want a really accurate risk score. I might just retry you later after you have more after you can give me a better response. Then they can wait like a few more seconds or maybe up to minutes. So you as a client have some flexibility as to how often you want to call signal. You can make the same call again like an hour later, and maybe get a higher fidelity response. But generally, we'll keep everything within seconds.
Awesome. And I see another question here that I actually wanted to ask myself too. So thanks for asking this. How did you decide on the model type that you're using? You said it's XGBoost. Do tree-based models always work better for a use case versus say using deep learning models or any other types that you may have experimented with?
I can only talk about what I remember because again, I joined Signal team in April this year. The XGBoost model decision was made in 2020. So partially it was just really easy to get started. And let's see, I think we had a lot of success using tabular data to feed into XG's model and being able to understand these are the Shapley feature importance values and so forth. So it, just from a development point of view, it inspires confidence to be able to make sense of the model, so to speak. We have experimented with deep learning alternatives, but at the moment, that's a fairly large departure from how we've currently been developing the ML system for the Signal product, at least. And it's unclear what the benefits are if all the data, input data are structured. And maybe last final bit is the cost. Potentially, I feel on the inference and even training side, the cost could be a little higher if we were to move into a deep learning setup. So a lot of questions. TBD, more research needs to be done.
Yeah, it's pretty interesting. I mean, like I see it across the board all the time how XGBoost just doesn't go away basically, and just still seems to be the most popular and widely used model type, despite all the fanciness and of deep learning and whatnot, because it just has undisputable advantages. Excellent, cool. You said that your answer triggered another thought. You said you have all structured inputs. Did you experiment at all with embedding input features into your XGBoost model, or is that something that you think you may experiment with down the road, or not really super useful right now?
We have a separate team, a different team that is how do I put it? Creating embeddings for us to consume, so to speak. And so we could just leverage their Python libraries or their microservice to figure out, given these transaction description, let's figure out what new enrichments we can use in our system to better predict the ACH debit transaction risk. So we have basically a service layer boundary between those teams that are more LLM and NLP focused and us. So yeah.
Have you experimented with that already, or is that on the roadmap to try it out? Or is that already part of the system actually to feed in these embeddings and they're part of the XGBoost evaluation?
It's already in the existing system.
Oh, okay. Yeah. Nice. Didn't even know. Cool, excellent. I think that is pretty much, oh no, more stuff's coming in here. Okay, let's see if I can maybe add one more question or so. Transformers seem to do better for structured data. Okay, are you incorporating features from external sources? We already talked about this one. How many people are on the NLP team?
NLP team? Less than 10 people. Yeah.
You seem to be super efficient over at Plaid. Seems like with a small number of people, you get an impressive amount of stuff done. Very cool. Cool. What was the performance of the embeddings in the fraud model? Is on the last question here from Christopher. Is there anything you can share about the impact that those embeddings had on detecting fraud?
So again, the embeddings were used mostly for just enrichment purposes and not directly fraud. I think some people actually experimented probably just like embeddings and predicting fraud likelihood directly. I don't know what the outcome was.
Excellent. All right. And with that, I think this is a good time to wrap it up here. Renault, I really want to thank you for taking the time here to so generously sharing some insights about the ML platform team, the Signal use case, of course, also how you've been using Tecton over at Plaid. So thanks so much for that. Also want to put a quick plug out there for our next Apply conference. If this is the type of content and the type of conversations that you're really curious about and want to see more of, I'd encourage you all to sign up for our next Apply conference on November 14th, where we bring together more practitioners who have a lot of experience putting machine learning applications into production. And they share with us what their best practices are, what mistakes they've made, and what's worked really, really well. And then we also have an upcoming virtual hands-on lab where you can try out Tecton for yourself if you are curious. So thank you very much, everyone. Feel free to reach out to me anytime, Kevin at tecton.ai. And thank you.